The rate of consumption of cola, which I think is funny because we don't say cola in Texas very often, okay? In the United States is given by S of t equals CE to the KT, where S is measured in billions of gallons per year and T is measured in years from the beginning of 1980. Whoa, I could have moved it down. Sorry about that. So where should we start for problem A? Problem A says the consumption rate doubles every 5 years, and the consumption rate at the beginning of 1980 was 6 billion gallons per year. We're supposed to find C and K. So where do you think I should start? With my equation, okay? So S of t equals CE to the KT power. Do you know anything? We do know C? What's C? Oh, 6. Right? 6 billion? Because it says the consumption rate at the beginning, so our initial consumption rate was 6 billion gallons per year. What do I put for C? Do I put 6 or do I put 6 billion?
6.
Why just 6?
Because that's what C is measured.
Yeah, S is already measured in billions of gallons. So we can just put in 6 right there. What else do we know? It gives us one sample, doesn't it? We know it doubles every 5 years. So after 5 years, 6ek to the K5, what should that equal? Yeah, it's 12 because our initial rate was 6. And if it's doubling, very good. Can I solve this? I mean, I know I can. Can you? That's just a little joke. Okay, so divide by 6. Good. Then? Out loud? Oh, 2 equals e to the, is it all right if I write 5k? All right. And then what? Logarithmic form. So what is it? Natural log of 2 equals 5k. So to solve for that, 5 by 5. So k equals the natural log of 2 over 5. So the natural log of 2 divided by 5. 0.138629. We okay so far? Have we answered all the questions on number 2, part A? What are we supposed to find? C and K. Haven't I done both of those? I just didn't write down what C was. I just kind of plugged it in up here, right? Remember our initial value was C, or 6, so that's what our C is, isn't it? Okay? If you feel more comfortable writing C equals 6 right here, that's great. If not, that's great too. Okay? Part B. Using the information from A, what will the consumption rate be in 1987? What do you know?
Time.
You do know the time?
Yeah.
What is it? 1987?
No, it's going to be 7.
What?
It goes from 1980 to 1987.
Oh.
It's 7 years.
So in part B, my T should be what? 7. Very good. So it should be S of T equals what again? 6 E raised to what power? Okay, 0.138629 times 7. Well, that seems real easy. Must be wrong then if I think it's easy.
No.
6 times natural log. No. Ridiculous. 6 times E raised to the, I'm going to go get that number. I just arrowed up. You can't really tell that it's highlighted unless I go like this where you can see it is. When I press enter, it'll pull it down. Times 7. So S of T equals what? 15.8341. 15.8341 what? Ooh, very good. Billions of gallons of soda. I'm sorry, I know it says cola, but I'm just going to write soda. Now, thinking about 15.8341 billion gallons of soda, that's making my arteries harden right now, because that's a lot of soda. Okay? All right, what about C? Do we have time to get through C? Okay, let's try. C. Using the information from A, when would you predict that the consumption rate will exceed 150 billion gallons per year? So what goes where? 150 equals 6 E T, right? Good. So solve it. See how quick we can solve it. Divide both sides by 6. $150 divided by 6 is 25. E to the 0.138629 T. And then, so natural log of 25 equals, and then divide both sides by that number, right? 138629. 0.138629. So, where did my stuff go? Uh-oh. Okay, I'm going to do this again. Natural log, what's it doing? Press menu, okay. Natural log of 2 divided by 5. Okay, so I have a natural log of 25 divided by that number up there. T equals what? 23.2193? 23.2193 what? Years? Does that make sense to you, or would you rather put it a different way? 23.2 years? I'm okay with that. Questions? We got it, yes? All right. At any time t is greater than or equal to 0 in days, the number of bacteria present, y, is given by y equals c e to the kt power, where k is a constant. The initial population is 1,000, and the population triples during the first 5 days. That's all given to us, right, in the first part of the problem, right? So now we start with A. Write an expression for y at any time t greater than or equal to 0. Well, where would we start? With the equation they gave you, right? Okay, good. Y equals c e to the kt power. What? Fill in what we know. That's exactly right. What do we know?
We know that C is 1,000.
We know C is 1,000. Why do we know C is 1,000? That's the initial population. Okay? Now here's the deal. I'm going to go ahead and write this out so I don't forget to in a minute. If I didn't know C was 1,000, then 1,000 would have to go in for Y, and 0 would have to go in for T. 0 times K is 0. E to the 0 is 1. 1 times C is C. So C would equal 1,000. So it's a lot easier if we can just remember that's where our initial population or our initial whatever is happening, right? Okay. Well, what else do we know? What else does it tell us? It triples in the first 5 days. How can we use that? We usually, if this is our initial value, what is this usually? It's our ending value, right? Okay, so what could I put in right here? Wait, why would I put in 3,000?
It's triple the energy.
Oh, it triples. And if it starts at 1,000, triple of that would be 3,000. You guys are so smart today. E to the k, which is what we're trying to solve for, times t. T being 5. Yeah, you're right. 5. Now what? What do I do?
You divide by 1,000.
Very good. Divide both sides by 1,000. Three equals e to the... Is everybody going to be okay if I write 5k? K5 is just fine. It's just, my math teacher brain. I got to put the numbers first. So weird. Okay. How would I solve for k now? Oh, write it in logarithmic form? Very good. Okay, what does it look like in logarithmic form? Ooh. Somebody can skip a step. Is that what you're telling me? You can skip a step? Should I write the step first and then let you know which one you can skip? Is that okay? Okay, so first it would look like log base e of 3 equals 5k. Except what he said was natural log of 3 equals 5k. He figured out that he can skip this step. Why can you skip this step? Because you know that log base e is natural log. This is the step you can skip if you want to, if your brain is there yet. Okay? If you need to write it down, you go right ahead. Okay? It's helping your brain process. You know I'm okay with that. Okay? But if that's a step you can skip, absolutely go ahead and skip that step. Okay? Now what? How do I solve for k? Close. Yeah, I got to get k by itself, right? I do that by dividing both sides by k. So k is going to equal the natural log of 3 over 5. Does anybody have a decimal estimate of this in your calculator yet? Yep. Divide natural log of 3 by 5. Two, 1, 9, 7, 2, 2. Now, why did I say a decimal estimate of this? Is this exactly what this is? No. So, this is what we're going to need to do later on. Okay? I want to keep that right there. I don't want to mess with that right now. Okay? I'm going to put that to the side, and I'll show you what we're going to do with it in just a second. Because, see, the problem asks what? What does it ask? Write an expression for y at any time. So this isn't my expression for y yet, is it? So y is going to equal what? What's my expression for y here? What do I know? 1,000. E. Don't I know k now? So 0.91722 times t. Oh, did I miss something? 2. I missed a 2. Sorry about that. Thank you. So what's my problem with this answer? I totally messed it up, didn't I? Should I try again? 0.21972 t. Is that better? Okay, sorry about that. Thank you. Sometimes I switch my numbers. Okay? What's my problem with this answer? What is it? It's an equation, isn't it? What does it ask for? An expression. Are you okay with that being my answer, though? Because it's asking me for an expression for y. I just wrote it y equals, and then that would be the expression for y. Are you okay with that? Okay, I just don't want to confuse your vocabulary mind. Because I know you were all thinking that. Yeah. Okay? Alright, so that's our answer for A. You ready to go to B? B. B says, by what factor will the population have increased in the first 10 days? So where should we start? Well, we should start with what we just found, right? Y equals 1,000 e to the 0.219722. Yeah, that's exactly right. I should put 10 in here. 10 is my time, 10 days, right? That's a real easy number to figure out because I just punched that in the calculator, don't I? Here's where I'm talking about, though, being careful. I'm going to say 1,000 e raised to what power? I want that number, right? I don't want to type in 0.219. I don't want to enter those decimals. I want to go get that whole number. Because look what shows up when I go get that whole number. Way more decimals, doesn't it? Times 10. Does it really make that big of a deal? 1,000 e 0.219722 times 10. Are those two exactly the same answer? No. This gives me the exact answer. This is an estimate. Okay? Sometimes we could probably figure out what it was supposed to be with our rounding issues, but sometimes we would get it wrong. So we can just go ahead and get it. Did everybody see how I went and got that number? I just arrowed up to what I needed, and then just pressed enter right where I needed it. You okay with that? Okay, just reminding you that you can do that. So when I did that, I got y equals 9,000. Is that my answer?
No, it's not that.
Yeah, the question asks, by what factor will the population have increased in the first 10 days? What is this 9,000? It's the actual population after 10 days. So what factor did the population increase by? It started at 1,000. Now it's 9,000. So it's an increase of factor of, you're exactly right, 9. 9 times. The population is 9 times, what, bigger? Or an increase of 9 times? Any of that would work. Everybody okay so far? All right. At what time this is letter C. At what time t in days will the population have increased by a factor of 6? What do you think? Where should we start? With our equation? Okay. Now go ahead and write that equation so we have it. Y equals 1,000 e to the 0.219722 t power. So what am I trying to figure out? I'm trying to figure out the time. So this is what I don't know, which means I have to know the y, don't I? It is. It's 6,000 because it wants to know when it's going to increase by a factor of 6. We know it started at 1,000. If it's increased by a factor of 6, now it's 6,000. Very good. Whoops. 722t. So let's solve it for t. What do I do first? Divide by 1,000. So 6 equals e to the 0.219722t. Logarithmic form, good. What is it? Are we skipping the step or not? Yes, okay, so natural log of 6 equals? Yeah, absolutely. Okay, how do I solve for t? 0.219722. 219722. So t is going to equal natural log of 6 divided by, I got to go back up and get this number. Because remember, I want the actual number, that one. So what t is 8.15465. So that answers the equation. What answers my question? What do I have to add to this to answer my question? Days? Have to have days, right? I don't have to automatically round this one to 9 like we had to do the other day, though, do I? Because can't you have partial days? Yeah, you can, right? They're called hours and minutes and seconds, right? That's the partial day. Milliseconds, we can stop there. We can stop there. Okay. Here's the question for you, though. Between these three answers right here, which one is more accurate? The first one, right? This one's the most accurate. Does 8.15465 days mean anything to you? Or 2/10 of a day? Like a fifth of a day? That makes way more sense, right? 8.15 even makes more sense than all of that. So here's the deal. Any of these answers on a homework problem or a test question would be acceptable. This one actually answers the equation. This one, to me, makes the most sense. So it might even be nice if you had like 2 of them. You see what I'm saying? Right? Because this shows that you know how to answer the question. This shows that you know how to answer, this shows that you know how to answer the equation. This one shows that you know what the question is asking. Fair? All right, any questions on number 1? Because that's it. That's all of question number 1. Good with that? All right, look at 2.